let's do this. We will go debug that later if you're curious to stick around. But what I want to go do, I actually want to do something different anyway. So let me just do a slightly more synthetic load, if you'll forgive me. And let's just make a file. Thank you. OK, so now I've done a much simpler operation of just making a file over and over again. And we can see the actual latency of the operation there. I don't know if you can see the clouds up there, but there are some, and it's amazing, 400 milliseconds is the scale there. Thank you, VMware. So what I want to do here is let's look now at the bottom of the stack instead of the top, and let's actually break down, let's look at the, excuse me for zooming in. No, don't do that. Thank you. There you go. Let's actually break down disk operations, and let's break down that by latency. So this is going to look at the bottom of the stack, and this is going to tell me how my disks are actually performing. And you can see here, even though we've got a virtual disk, it's still taking tens of milliseconds, or wow, 750 milliseconds, Jesus, to respond. That's like 1.2 seconds. Wow, that's a slow disk, a slow virtual disk. And one of the things you can do here is if you're particularly curious about where are some of those outliers coming from, let's take, say 43 milliseconds, and I can then further break down by disk. And what I've effectively done here, by the way, is we are visualizing that quantize operation, right? Instead of being ASCII art, I mean, that is a little better than ASCII art. I mean, that's a little better. I still love the ASCII art, but it's slightly easier to, you can certainly see much more interesting patterns here, especially over time. And you can see some very, very strange things here. And if we have time at the end, I'll show you some of the really odd things we've seen just by looking at latency in this way. You can stare at these things for a long, long time and reason about them. And one of the things that we were doing, and let's Control-C that. One of the things that we were doing with a similar kind of workload, we had a new JBOD firmware that had arrived, and we were looking at disk latency just like this. Let me pause these guys. We were looking at disk latency, and one thing that we noticed with this new JBOD firmware is that the disk latency had some really serious outliers, had like 800 millisecond outliers when we were pounding it with I/O. And this was a bit of a mystery. We didn't really know what was going on. But you could see that band very clearly. One of the nice things about visualizing the data this way is you'll see very clear banding when you've got some sort of issue going on. And we saw a very clear band at 800 milliseconds. And we just taken a new firmware drop for this JBOD, a JBOD which struggles with firmware issues. We're in a bit of a firmware crisis, by the way. We collectively, we humanity, are. That'll be the subject of my next rant, but not now. Corner me afterwards if you want to talk about the firmware crisis. Anyway, it was my natural assumption that the firmware guys screwed up again, and we're seeing these high outliers because of the firmware drop. Well, so we're looking at this output, and one of my colleagues was like, well, let's just break down, let's take some of the outliers and break down by disk. And I'm thinking, no, that's a stupid thing to do. Because we know if you're going to take the outliers and break down by disk, you want to show which disk has these 800 millisecond outliers. We know that it's going to be evenly distributed across all disks because it must be related to the firmware drop we just took. It's amazing. You would think by now, I mean, I've probably run DTrace, 100,000 times in my life? I don't know how many times. You think by now I would stop guessing because I'm so frequently wrong. Right? Indeed, that's the reason we developed DTrace, is because I know how frequently wrong I am, how frequently wrong we all are. And even as he was doing it, something like, this is a waste of time. But we get the answer back, and whoops, not a waste of time, because it's not every disk. It was one disk. There was one disk that was responsible for essentially all of those outliers. What the hell? What's that about? And then we're kind of like, what could be causing that? And we're looking at the smart data. Smart data. It's like, no, I'm cool. I got no problems. Like, no, you've got problems, my friend. I know you have problems. It's like, no, I don't know what you're talking about. It's like it's not physician heal thyself. It's more like policeman police thyself. And it does not work, needless to say. The smart counters are often 0 for drives that we know are behaving strangely. What the hell is going on? Well, so someone finally is like, let's go look at the drive. I'm like, no, you're gonna go look at the drive? Like, what do you think, there's like a raccoon that's like chewing on the drive? I mean, like, what are you talking about? Like, what, it's gonna be on fire? I mean, like, that's a dumb idea. But I didn't say that because it's like, I didn't have any good ideas. Like, I had nothing but dumb ideas. So like, all right, let's do your dumb idea instead of my dumb idea. And in particular, we saw that, again, here we see that the disks are pretty evenly distributed, which is a relief. That's what you'd expect. But if we look at, like, let's look at one of those samples there, and let's hierarchically, that should be pretty evenly spread. I wouldn't expect VMware to be biasing its latency towards any one disk. It's a little bit biased maybe, but not too much. But in this case, it was all one disk. Well, so how do we figure out where HDD11 is in the system? Well, this is one of those problems that the delivering of an appliance gives us the luxury of solving. If we go over to our maintenance hardware view, we can actually get a physical view of the machine. Now, this is a virtual machine, so that's just kind of a made-up machine. But if you go onto one of your appliances, you will find that this is an actual image of your machine, and you can go click on the disk, and it will highlight it. If you have a real machine, you could then go click on, there's a button out here, you can actually light the LED on the disk, which you should primarily use as a way of screwing with your colleagues. Can you just go into the server machine and change the disk with the LED that's lit? And then you can be like, da, 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 and they're kind of there, like, seeing the LEDs are, it's like, what's your problem? I just told you to change the disk. It's like, the LED was changing. Oh, the LED was changing. Yeah, OK, got it. Oh, that makes sense. Sucker. That's really what we're trying, that's always what we're trying to develop, is really preeminent frameworks for elaborate pranks. That's really what it is, the mother of truly all invention. But you can actually light the LED. And so we did this, we lit the LED, and sure enough, a raccoon had broken. No, I'm kidding. So we go in there, and we find the lit drive, and we pull it out. And again, I'm a total cynic or skeptic. I'm like, what the hell are we doing? Pull the drive out, and the three of us, like, I could feel the breath exit us, gasp. And we looked at the drive. The drive was missing 3 of its screws. It's like, whoa. Raccoon theory comes back. Right? It's like, you're missing 3 of it. It's like, this is a vibe problem? I mean, it makes sense when you think about it. It's like, I mean, the screws are there for a reason. And I mean, of course, something that doesn't have any, that is not mounted has lost its mounting screws. And this, by the way, is not a drive that I put in. So the screws must have been there when the drive went in. Somehow the screws have presumably shaken themselves out. We're still kind of disbelieving it. And we put the screws back in. It's like, this is a vibe problem. And we put the disk back in, and it's a champ. 800 millisecond latencies go away. Wow, that was a loose screw. That's scary. And then we're like, oh man, we should have blogged all that. Like, that was really interesting. Like, the fact that we used analytics to discover a loose screw, like a real loose screw, not like you denigrating your VP, but actually a loose screw. All right, so let's go back in. Let's take the screws out. And we'll go take the screws out of the drive, put the drive back in. Of course, now the thing is a champ. It's like, oh, God. Which makes sense, unfortunately. So if you've dealt with vibe problems in the past, vibe problems are very, very finicky. They often are, there's often an interference effect to it. You often have positive interference. You distort the system a little bit. This is why you make vibe problems go away by changing the system, which is really, makes them very, very difficult to debug. So if you've dealt with vibe problems, unless it's an actual bad component that's inducing the vibe, they can be really tough to debug. So we take the screw out, of course, and it's like, all right, well, this makes sense, but it's so frustrating. So then we start taking the screws out of every bracket. And we've got so every drive is just like sitting there on its mounting bracket. You're like, come on, damn it. And still nothing. You're like, oh, stupid drive. Why can't, you cannot behave so many other times. Why can't you just misbehave when I want you to misbehave? So we were talking about this, my colleague and I were talking about this, and one of the things that we were talking about, just kind of went over to lunch, so we had we're all in the wrong business, by the way. We should all be in the data center fire suppression business. That's where I don't know if you actually cut your checks to Fenwal, you pay like $50K for a canister of gas. That is where the real money is made in our industry, by the way, in terms of fire suppression. And we had inherited, we had an old MCI data center that I swear was cleaned out by ex-MCI employees who had the car running out front because they just sliced through the cables, took all the infrastructure out. But honey, they were professionals. They took the Fenwal. Somebody knew what they were doing because they took that goddamn canister of gas.